Hello and welcome to lesson 4A. I can use theorems about isosceles triangles and midsegments to find missing values in triangles. We learned in unit 1 that an isosceles triangle has exactly two congruent sides. In this case, my two congruent sides are the here and here, and we call them the legs of the triangle. Okay, those are my congruent sides. The side that's not congruent, we refer to as the base of the triangle. That's my non-congruent side. Now, angle-wise, you actually have you have the vertex angle at the top, and it's included between your two congruent sides, and then you have your base angles at the bottom. And your base angles actually happen to be congruent. So this guy would be congruent to this guy. Now we actually are able to prove that. We know that if a triangle is an isosceles triangle, then the base angles are congruent. We can prove this actually. So if I'm given triangle ABC where AB is congruent to CB, I'm now going to prove that angle A is congruent to angle C. So let's start off by drawing a picture of what's going on here. I have a triangle ABC, and they tell me that AB is congruent to CB, okay? So before I do this, we have a couple of ways to prove things congruent, and usually it's using CP/CTC, which involves proving some triangles congruent. Now, just given the triangle as I have it right now, it isn't quite as useful. So what I'm going to do, I'm actually going to add something to my diagram. I'm going to draw on a line here, and I'm going to call this point right here D, and I'm going to let line BD be the angle bisector of B, which is going to let these pieces here be congruent. So then I'll also have a reflective piece here. So I'll be able to prove my triangles congruent by SAS, and then use CP/CTC to prove A congruent to C. That's the plan for my proof. But let's talk about how we'll actually show this in our proof. So go ahead and set up your T-chart. We have statements and reasons. And we have our givens. Given triangle ABC, where AB is congruent to CB. That's my given. And then let's talk about what we added to the diagram. We actually did a construction. I mean, not with a compass, but we constructed segment BD to be the angle bisector of angle B. And what allows me to do this is basically just by construction. We didn't change it. Doing that didn't change any of my givens. It didn't change the triangle. It didn't change the fact that AB is congruent to BC. I'm allowed to do it. It just makes it so I can actually prove some things congruent here. So my third step, I'm actually going to talk about why it's important that that's an angle bisector. Well, that allows me to say that angle ABD is congruent to angle CBD by the definition of angle bisector. And we also need to talk about that reflexive side, that share side. Remember, I'm trying to get to SAS. I currently have a side, and now I have an angle. I need my second side. So I can say that BD is congruent to BD by the reflexive property of congruence. And then we're able to say in step 5 that those two halves of our triangles are congruent. I can say triangle ABD is congruent to triangle CBD by SAS. And again, if I'm able to show that my two triangles are congruent, then I can prove with CP/CTC that their corresponding pieces are congruent. So I can say that angle A is congruent to angle C because corresponding parts of congruent triangles are congruent, CP/CTC. And that's it. We have proven that the base angles of isosceles triangles are congruent. So let's take a look at how we can actually solve some of these things algebraically using that. So if I know that this is an isosceles triangle, then I know that this angle and this angle here are congruent. Now I don't have anything right now for this angle, but I do know that this angle and the 5x add to 180, which means that the measure of this angle is 180 minus 5x. Okay? Well, we know that these are congruent, so I can say that 180 minus 5x is equal to 2x minus 30, and I can solve that. So I end up getting, add the 30 over here, 210 is equal to, add the 5x over here, 7x. So I get that x is 30 degrees. Easy enough. Now looking over here, I have an isosceles triangle. If these are my congruent sides, then my base angles are now here, they're congruent. So if this is 3x, this is also 3x. And we know that all the angles in a triangle add up to 180. So I can say 3x plus 3x plus 4x minus 10 equals 180. So that becomes 10x equals 190, or x equals 19. That's all you got to do. The next thing we're going to learn about in this lesson are midpoints, or midsegments. A midsegment connects the midpoints of two sides of a triangle. And so when I draw this in, I have a midpoint that would go to here and another midpoint on this side, which should be roughly here. And when I connect these, we create a midsegment. This right here is my midsegment. We actually have 3 of these on every triangle because I could also find the midpoint down here. It'd be roughly here where this would be congruent to this. And when I connect, we create 3 midsegments. And the midsegment of a triangle actually has some pretty cool properties. It is both parallel to and equal to half the length of the side opposite it. So right here, this midsegment BD, it's going to be parallel to AE, and it's also going to be half the length of AE. So the honors problem set is actually going to prove that that's true, but we're just going to use it now to solve some problems. So looking over here, I have a very, very funky looking triangle, and you can see here that IK is the midsegment of FH. I think we were supposed to be given that. Let me rewrite that. We're given that I is the midpoint of segment GF and K is the midpoint of segment FH. So if I'm looking at my midsegment IK from I to K, it is parallel to GH. But it's also parallel, if you look, we even have a tiny triangle right here where LM is the midsegment and its opposite segment IK, so IK is also parallel to LM. So we've got like a triangle within a triangle within a triangle. So if they tell me that from G to J is 8, well, we know a lot of things. If G to J is 8, then J to H is also 8 because it's because they're marked congruent. And that means that from G to H must be 8 plus 8, which is 16. Well, IK is the midsegment that's parallel to an opposite from GH, so it's half of 16, which is 8. And LM is the midsegment of this tiny triangle here, and it's opposite the 8, so it must be half that length, it's 4. Okay, so we know that GH is 16, IK is 8, and LM is 4. All right, guys, that's all I have for you right now on isosceles triangles and midsegments. If you have any questions, please come and ask. Otherwise, take a look at the MML.